the first page of the packet. Problems you want to see work. Which one? 13. Problem 13. On problem 13. I'm not actually going to do 13. I didn't realize it was on there. Just because I didn't stick anything like this on the test about coordinates and stuff. I'll sort of draw it real quick, but I'm not going to go all the way through it. There won't be anything that deals with drawing these on a coordinate system. It says E is 1, 1. That's E. What else do they tell us? C is 4, 1. That figures. I drew my letters and stuff right where I need points to be. Find the coordinates of G in quadrant 1. So G's got to be in here somewhere. That makes it a 30, 60, 90 triangle. So for this to be a 30, 60, 90 triangle, let me redraw this so I can put my letters somewhere else. It has to have a right angle. Good. So we got 1, 1, 4, 1. So that's one of the sides of the triangle. If it has to have a right angle in it, how's this other side from this point going to go? Maybe straight up, something like that. And then the other one's got to connect to that, right? Now, when we draw this, we don't want to make it so big that it goes up and forms some other kind of triangle. We want it to be a 30, 60, 90 triangle, or you could draw it. Change my color again here. You could draw it up higher and make that the 30-degree angle and that the 60-degree angle. Or you could come over here to this point and do the same thing. So there's like 1, 2, 3, 4 places where it could be. And that's why I'm not going to go through all that. But you could probably go through and figure out by counting this how long this side is. Well, from 1 to 4 is 3 spaces long. If that's the side across from the 60-degree angle, it has to be a certain thing. If it's across from the 30-degree angle, then it has to be labeled L, so on, so on, so on. So you could go through and figure all that out. I won't put anything that difficult on the test. Number 1 on the same page. On the first page. Hopefully everybody's paying attention because I'm going to start calling on people. Mickey, what kind of triangle we got there? That's true. What else?
Right?
30, 60, 90. As soon as you see it's a 30, 60, 90 triangle, you might want to have out your notes if you don't remember this stuff. The side across from the 30-degree angle should be labeled what, Jason? Side across from the 30-degree angle.
It's like an L, right?
L. Very good. Side across, the hardest one, side across from the 60-degree angle should be labeled what? Go ahead, Zach. Thought you said it. L square root of, somebody help him out to make sure. 2? 3? Which one is it?
2. It's 3.
2. 3?
3. 2.
It's 3. Make sure you don't get those mixed up. The radical 2 goes along with what kind of triangle? 45, 45, 90. The radical 3 goes along with the 30, 60, 90 triangle. The way I remember that again, radical 3 because of 30, 3 and 30. Side across from the right angle should be labeled, what should the side across from the right angle be labeled, Natalie? 2 times L or 2L. That's the one that they told us something about. So we set up our equation from that. This is where you guys have trouble. You got to make sure you label it. They tell you one of the sides, and then you set up an equation from that information. So what's our equation going to be this time, anybody?
2L equals 24.
2L equals 24. How do we solve for L then?
Divided by 2.
Divide by 2. So what's L equal?
12.
So everywhere I see L, what can I replace it with?
12.
12. How long is this side over here then? So this side's 12. How long is this side? 12 times the square root of 3. Don't make that harder than it is. Can you just leave it that way? That's your answers. 12 square root of 3. Sometimes they'll ask you to solve the whole triangle, and that just means find all 3 sides and all 3 angles. Do we know all 3 sides and all 3 angles now? Yeah, we filled this in. So that was the other angle that we didn't know from the beginning. We filled it in. We found this side. We found that side. We already knew that side. We knew that angle, knew that angle. So we solved the whole triangle. Problem 6 on the first page. What kind of shape is that supposed to be that mine doesn't look like? It's supposed to be a square, right? And they tell us that each of these sides is 13. And this is X. That's the angle. And this is Y. What kind of triangles are these 2 triangles in?
Right triangle.
45.
45, 45, 90. They are right triangles, but a better name is 45, 45, 90, right? So if I split off one of the triangles, it's a terrible looking drawing. This is Y, this is 13, this is 13, this is 45, this is 45. The sides across from the 45-degree angle should be labeled what, Lexus? You just knew I was going to call on you, didn't you?
L.
L.
13. Or, yeah.
It's L, you're right. So this should be L, this should be L.
Yeah.
The side across from the right angle in a 45, 45, 90 triangle should be labeled what, Trey?
L square root 2.
Very good. L radical 2. Which one of those do we know this time? The L. So what equation do we set up? L equals,
13.
how do we solve that?
You don't.
It's already solved. So anywhere you see L, what do you stick in?
13.
13. So how long is this side?
13.
13 times the square root of 2. That's your answer. X, how do we find X? You guys already told me, but we didn't write it down. What do you know about that angle right there? It's 45 degrees. So X equals 45 degrees, and Y equals is 13 radical 2 right there. Anytime you have a square, you draw in a diagonal, you're going to form 2 45, 45, 90 triangles. So something easy. If I had this square and I told you every side of this square was 5, without going through all that headache that we just went through, anybody tell me how long that diagonal right there is? 5 radical 2. If I had this square and I drew in this diagonal and I told you this side was 15, how long is that diagonal? 15 times the square root of 2. On a baseball field, never thought you'd use this. Truck. Did you catch?
No.
I was thinking you were.
Trade.
You're a catcher? Do you know how far you got to throw it from home to second base?
Too far.
Too far, because you can't throw it that far, right?
No.
I've seen you throw every now and then out there playing pass. Yeah, I have.
I have to. I've
Not,
passed
not,
with it.
not very good, is it?
I've passed with
If you're,
He did
My-
pitch rec ball last year.
my, my son's a catcher, so I know this. You throw from home, how long is the bases? 90 feet. You throw from home to second base to get a guy out when they're stealing, which doesn't happen real often in high school baseball. Usually Guys stealing, they can steal pretty easily. You usually don't send some slow guy to steal, right? How far does the catcher have to throw the ball?
27 feet.
What is it in math terms?
90.
90 times the square root of 2. So when Trey's out there catching and his coach yells at him because he throws it to here instead of to the base, he can say, "Coach, I almost threw it 90 radical 2 feet." And then your coach will stop and he'll quit yelling at you because he'll be confused.
He'll make him run a cold until he understands.
So Trey, what is 90 radical 2? Use your calculator there, Trey. What is 90? All right, back to math. Number 8. On the front page again. What kind of triangle are they giving us there? 30, 60, 90. Before I even look at what number 8 says, the side across from the 30-degree angle should be labeled what? L. Side across from the 60-degree angle? L radical 3. Side across from the right angle? 2L. What information do they give us in number 8?
B equals 15.
Little b equals 15. Where's little b located at in this picture?
Between A and C.
It's across from the big B, right? So this is little b over here and it's 15. What equation do I set up? This is the harder problem, so watch carefully on this one. These are the harder ones that you have to be able to do. What's our equation?
15 equals L radical 3.
15 equals L times the square root of 3. How do you solve for L? What do you do? What would you do if it said L times 7 equals 15? Divide by? All right, so you divide both sides by radical 3. Don't make this harder than it is. Now, if I say give the exact answer, which in this case, did they say give the exact answer? No. So if I say give the exact answer, then you got to work it through doing all that stuff with that radical. If they didn't say that, you could cancel these out right here and say L equals, and how could you figure out what 15 divided by the square root of 3 is? Use your calculator and figure it out and give the decimal answer. I'm going to go ahead and figure it out the long way. Remember, when you got 15 over radical 3, you can't leave the radical 3 in the denominator. Some of you might want to write this down to make sure you remember it. You multiply the top and the bottom by the square root of 3. 15 times square root of 3, you can't multiply a regular number times a radical, or you can't do anything with them, so you just put 15 radical 3. Square root of 3 times square root of 3, what's that give you? Square root of 9. What is the square root of 9? 3. So you're left with just 3 on the bottom. Remember, when you're doing this, the whole purpose is to get the radical out of the denominator, and the radical sort of just disappears and leaves you with that number. That's the whole purpose of doing it. Here, what can you do with the 15 and the 3? If you forgot that radical was there, reduce it. What is 15 divided by 3? 5 over 1. Do we need the 1 on the bottom? So what's L equal this time? 5 radical 3. I bet if you take your calculator, some of you grab your calculator and divide it out here. I bet if you take your calculator and hit 5 times the square root of 3, it gives you the same answer that you got before. So this side right here, or L equals 5 radical 3, so this side is how long? 5 radical 3. That's one of your answers. If you double that, 10 radical 3. Remember, you just double the number outside. If you got 5 radical 3's in this hand and 5 radical 3's in this hand, you put them all together, how many radical 3's you got? 10 radical 3. What happened? Number 10 on the second page. They give you a triangle that looks like this. I know my triangle probably doesn't look exactly like theirs, but it'd be close enough. And they say find the sine of angle A. Can we use the 30, 60, 90 and the 45, 45, 90 stuff that we've just been using? No, because do we know these angles are 30 and 60 or 45 and 45? So as soon as you see that they're not 30, 60, or 45, you know you got to use one of the trig ratios. So sine of angle A. Well, before I can find the sine of angle A, how do I know I'm dealing with angle A? They told us, right? You got to label the triangle every single time, and for the rest of this packet, this is what you got to do very first thing. What's that side over there going to be labeled? Opposite leg. So everybody remember that. How do you know it's the opposite leg? Because it's opposite the angle you're dealing with. It's opposite, it's straight across from the angle you're dealing with. What's the side across from the right angle going to be labeled? And the side that's hooked to the angle you're dealing with? Adjacent. Remember your SOHCAHTOA? Which one are we dealing with here? The SO, the CA, or the TOA? So sine, that's what the S stands for. What's the O stand for? Opposite over hypotenuse. Well, what is the opposite this time? What's the hypotenuse? Will that reduce any? That's your answer. They said they also wanted it in a decimal form.
You said don't worry about it.
I said not to worry about it. I really don't care. But if you wanted to change that to a decimal form, how would you do it? Just take your calculator and divide. 40 divided by 41. Don't make it harder than it is. Don't be hitting the sine or cosine button when you're just trying to divide or multiply or whatever else you're doing. Problem 19 on the second page. This is the same kind of problem that we just got done doing. Yep. What are we looking for? Well, the extra that we just did. What are we looking for this time? X. And that's an angle, right?
Yep.
What's this side going to be labeled? Opposite leg. What's that side going to be labeled? Hypotenuse. This side over here then is the adjacent leg. Which two do we care about? I heard opposite, adjacent. Everybody agree with that? Which one don't we care about? We don't care about the hypotenuse this time. We don't know it. We're not looking for it. So we just don't even care about it. You got SOHCAHTOA. Get tired of writing SOHCAHTOA. Which trig ratio, sine, cosine, or tangent, deals with opposite and adjacent? That's the hardest part of any of these problems that we're doing, is figuring out which trig ratio you're using. And you do that by the sides that you're given or the sides that you're looking for. When you're writing your equations, and that's the way the whole rest of this packet and what you're going to do for homework tonight is going to be. You're going to write an equation every single time and then solve that equation. You write your trig ratio. What always comes right after the trig ratio? The angle. Well, what's the angle this time? X. We don't know it, so you put an X there. Equals, and then you write your fraction. So trig ratio, angle, then the fraction. What's the fraction going to be this time? 27 opposite over 8, which is the adjacent. Since we're looking for the angle, what do you hit first on your calculator?
Second.
Hit second. So grab your calculator, hit second. Which trig ratio do we hit this time? What do we put in? 27 divided by 8. What's it come out to be? 73 degrees. Everybody agree with that? Anybody not get 73 degrees? Again, if you didn't get it, don't sit here and say, right, Lexus? Don't sit here and say,
I got 74 because I rounded up.
okay. But I remember last class you said I wasn't getting those answers, and I wanted to make sure. So if your calculator or something is set up different, I'm not going to yell at you. I'm going to yell at Lexus now because she didn't bother to tell me last time. But if Tristan's sitting here and he's not getting these answers as we're doing it, and he doesn't bother to tell me, I'm not going to yell at him because it's probably just his calculator is set up wrong and I need to fix it. All right, that ain't his fault. I might yell at Cameron just because it's fun to yell at him. Number 4 on the third page. Have you seen a problem like number 4 before?
Yeah.
When?
When we were doing,
About 30 seconds ago when we were doing the last problem. What are we looking for this time? An angle, right? What's this side going to be labeled? Opposite leg. What's the side across from the right angle always labeled? And then the other side's the adjacent leg. Which two do we care about this time? Which trig ratio deals with adjacent and opposite, or opposite and adjacent? Tangent again, so you write down your trig ratio. Again, every single time you're just writing an equation. Trig ratio, what comes next? The angle, which is x this time. Then your fraction, what's your fraction going to be this time? Remember, it's opposite over adjacent, right? So 4 over 1. Well, if you're looking for the angle, what do you grab? Grab your calculator, punch in, hit. What do you hit first? Second, tangent. Some of the calculators actually have a sine -1 button on them. That's what I'm trying to get to. If some of you have that, then know you hit that sine -1 button. That's probability.
Yeah, it is.
You got to hit it before you.
No, like you gotta get second.
Ah.
It was a circle.
Trig. I don't think I've ever seen one like that. So, now maybe I did see it when, because Kyle showed it to me, I think, last class when I had him.
Yeah, this is Kyle's.
So you had tangent that, put that in your calculator, hit enter. What's it tell you x equals? 75, 76, which one?
75.9.
Yeah.
So round it up to 76 degrees. Do what? So that's 76 degrees. How could we find that angle?
Add 76 and 90 and subtract 2.
Does anybody see an easier way to find that angle? If it's a right triangle, what should these other two angles always add up to be?
90.
90. So if that's 76, what's that one going to be?
13.
Close.
14.
14 degrees. The two, don't let them laugh at you because they didn't even answer it.
I'm stupid.
We know, Bree.
Yeah, I bet you got it right.
We know.
Huh?
1 on the third page. Number 1. Then I'll do one more after this on the third page. This time, instead of looking for an angle, what are we looking for? A side. So follow along if you're not sure. Did I just draw that wrong? No, it's sort of right. I think I drew the wrong triangle with right numbers. Again, first thing you're going to do, which angle are we going to deal with here? Do I want to deal with the right angle? Never. Do I want to deal with this angle? No, because I don't know it. So which angle are we going to deal with? 28 degrees, and that's how we label our triangle, from that angle. Side across from the 28 is labeled what? What? The opposite. The side across from the right angle is labeled what, Cameron? There you go. And then the 32 here is going to be labeled adjacent. Which one don't we care about this time? Is anybody seeing a pattern where you don't ever care about the hypotenuse? That's a lot of the time. And when you don't care about the hypotenuse, what trig ratio are you using a lot of the time? The tangent. Especially in real life problems. Remember all those problems we did with the sun shining down on something?
Yeah.
You got a person standing here and the sun's shining down on them and they form a shadow. Well, the hypotenuse in that case is the sun's rays. And I know Lucas probably does it, but most people don't go out and try to measure the sun's rays.
Of course it does.
I know Randy sends him outside and says, hey, go out and catch me a few beams of sun. And Randy watches out the window laughing at him because he's out there trying to.
I'm smarter than I use a jar.
He's standing out there with a bucket,
He's out there with a bucket.
catching them.
I use the lid too.
You guys know you guys know too much about that, Charles, so I'm guessing that your dad has done that to you at some point. All right, so if we look at this, which trig ratio are we going to use? Tangent. Remember, you write your trig ratio. What comes next?
28.
28. It's always your angle next. Equals
X over 32.
opposite over adjacent, so x over 32. Watch carefully on this because this is more like the problems. Usually you're not looking for the angle. Usually you're going to be looking for the length of something. Okay? So this is more like the problems we're going to do most of the time. When you know the angle, first thing I want you to do, once you have your equation written out, put a 1 under that. Why do I put a 1 underneath that? Makes it look like a fraction, a proportion. Next thing you want to do, you don't want to cross multiply next, because what's 32 times tangent? You guys didn't learn that when you learned your multiplication facts? 7. 32 times tangent is 7, Trey says. Don't believe anything Trey says for the rest of the year now, because I don't know where he got that from. So what you got to do is take your calculator. Don't hit the second button this time. Hit tangent, 28, and hit equals.
0.6248.
That's not what I got. Wow. You guys are getting a bunch of crazy answers.
I got
Maybe my calculator's messed up. No,
Maybe it's not meant for a computer.
my calculator's right.
0.539.
That's what I got. How many places should we go out? 4. 5, 3, 1, 7. Does that look right?
Yeah.
Those of you, if you didn't get that, try it again. And let's make sure that your calculator's doing it right. You got it? You hit the second button, didn't you? Well, I mean, you hit the, once you got in there, you hit the tan -1. Everybody see how we got that? Put a 1 underneath that. Fraction on the other side stays the same. Now what do we do? Cross multiply. That's all you got to do, cross multiply. What's 1 times x? X. Grab your calculator again. What's 32 times 0.5317? Just go out one place behind the decimal this time. What is it? 17.0. Is it necessary to put that 0.0? In math class, not really, but if you go to a science teacher, are they going to tell you? Sig figs. Because that tells the next person who looked at it, looks at this answer, if you just put 17 down, that next person's going to think you rounded it off to the nearest whole number, right? If you put 17.0 down, they know you rounded it off to the nearest 10th. And that tells them, hey, you're being pretty precise. So that's the answer to, what, number 1? Questions on the last page, problems you want to see worked?
All of them.
That ain't going to happen.
Number 1.
Number 1. You guys can smack Lucas here in a second for asking for this question.
Is it easy or something?
Yes, very.
Well, then can we do number 2 instead?
Yeah, it's the same thing as number 1.
Can we do number 5 instead?
Too late now, it doesn't start it.
Oh, come on.
What's this angle? Do it after my class though, so I don't have to mess with it. What's this angle right here called? Angle, then we give you two choices.
The last two.
Angle of elevation. How come it's called an angle of elevation?
This goes up.
Because it goes up. So I'm standing here, that S, that's me. I'm standing here, I look straight out, and I look up. What kind of angle am I looking at? What kind of angle is that? Angle of elevation. What's the other angle called? This angle right here, what's it called?
Angle of depression.
Angle of depression. Don't make angle of elevation, angle of depression harder than it is. The only reason you even need to know those terms is because some of the word problems that they do will say something like, John is standing on top of a cliff, and he looks down. He looks out, and then he looks down, and he sees his girlfriend standing down here.
With no arm.
And don't laugh at John's girlfriend, Cameron, because your girlfriend probably won't have legs either. And she'll probably.
That's cool. What is that?
So, John's angle here, this angle right here, they'll say his angle of depression is 32 degrees. And you might need to know that. Now, is his girlfriend's angle, is that going to be an angle of depression? No, that's going to be an angle of elevation. Now, what you need to remember with stuff like this, if I draw this and make this a rectangle, this is her angle right here. This is John's. Well, John's angle of depression is he's looking down at her, and her angle of elevation is she's looking up at John. What do you know about those two angles?
They're congruent.
They're congruent. What kind of angles are they to each other?
Alternated.
Alternate interior angles. So you need to realize stuff like that, because a lot of times they'll give you something like they might give you John and say this is 32, but then they'll say that his girlfriend's down here and she's 100 feet from the cliff. Well, if that's 100 feet, what's this top one up here? And you can transfer that up there and then just use one of the triangles instead of have to deal with both of them. But those are your two answers on number one. Other questions on the back page? What'd somebody say?
Lucas said 5.
5?
Yeah, it's fine.
Number 5. I don't feel like reading that again. On a mountain bike trip along the Gemini Bridges Trail in Moab, Utah, Nabucco stopped on the canyon floor to get a good view of the twin sandstone bridges. Nabucco is standing. Nabucco is standing about 60 meters from the base of the canyon cliff, and the natural arch bridges are 100 meters up the canyon wall. If her, I thought Nabucco was a male name because it ended in up, but I guess not. If her line of sight is 5 feet above the ground, what is the angle of elevation to the top of the bridges? Round to the nearest tenth of a degree, and again, you can round it to the nearest degree if we're finding an angle. So this is number 5 on that back page. Got this person standing here. They look straight out. Apparently there's some cliff or something over here, some rock wall. And somewhere up here on this cliff, there's some bridge or whatever it is. So they look up at it. Now my picture in no way, shape, or form is drawn to scale. What they tell us about Nabucco's height.
5.
And they told us that this right here was how far off the ground? 100. So from here down is 100 meters. Ground's down here. Make sure Nabucco's standing on the ground. And Nabucco is how far from the rocks?
60 meters.
60 meters. Do I need all that whole picture? No, I just need the triangle. So I have this triangle here. How long is this side of the triangle? Very good. Be careful. How long is this side in the triangle? 95. How'd you get that? All right. So we didn't want this part, so we had to subtract off the 5, so that's just 95. And we're looking for the angle of elevation that Nabucco's looking up there at. What's that side got to be labeled? Opposite leg. What's this side got to be labeled? I hope everybody's watching, because here in a minute, after we're going to do one more problem off this page, then I'm giving you a worksheet, and you guys are going to come up here and work them. So if everybody's paying attention, let's hope. What's this side over here labeled? Which two do we care about?
Opposite.
Don't care about hypotenuse again, right? Which trig ratio? Remember your SOHCA, TOA, tangent, right? So we write tangent. What's our angle this time? X equals what over what?
90/60.
Good.
95.
95 over 60. When you're looking for an angle, what are you going to hit first on your calculator? So grab your calculator, hit second. Then what button do you hit? Tangent.
95/60.
Then 95 divided by 60. Hit enter. Charles says 58 degrees. Anybody agree with that? 57.7. So 50, if we round it up, 58. I know they said round it to the nearest 10th. Either one, if it says round to the nearest 10th and you put down 57.7 degrees, or if you actually listened at some point when I was saying always round your angles off to the nearest degree, I'd give you either answer. So, what was it, 58 degrees? So this angle right here, again, my picture looks absolutely nothing like it. It probably should look something more like this, where you got the cliff going up. This person is actually looking up at a decent angle. They're looking up like this to see it, not just sort of looking. Other question? Shelby, you getting all these? You understand them all?
Yep.
Last class you were answering all kinds of questions and stuff. I'm worried that today we went back to drawing pictures instead of answering questions. I would be wrong, wouldn't I?
Yes.
Okay, just wanted to make sure. From her position in a hot air balloon, Angie can see her car parked in the field. I'm not going to draw all this. You got the person up here. That's Angie in the hot air balloon. Her car's down here somewhere. She can see her car. If the angle of depression is 8 degrees, so her angle of depression, she was looking straight out of the hot air balloon, and she looked down and seen her car. So that angle right there is 8 degrees. And Angie is 38 meters above the ground, so right here she's 38 meters above the ground. Well, if I complete out this rectangle, what's this side over here in this triangle going to be? 38 meters. What is the straight line distance from Angie to her car? Now, here's where I'm going to show my ignorance. I have no idea what they mean by straight line distance. I don't know if they want, to me, straight line distance would be that distance. But I'm sure a lot of you probably think, all right, if you're measuring the distance from her to her car, you want that distance. So pick me one. That one or that one. Which one do you want to find? 2? So we'll do 2. We'll call this a straight line distance. I don't have a clue which one they actually want because I don't know what straight line means. Number one, because what have I told you all year long?
All lines are straight.
All lines are straight. Why you would ever say straight line I have no idea, because if you say line, you know it's got to be straight because it's a line. So don't say straight line. I have no idea why this book says it. But we're going to look for this time. So that'll be x. That's 8 degrees. This is 38. Which angle are we going to deal with in this picture? So we label the triangle according to that angle. What's this side going to be? Opposite. Side across from the right angle is the hypotenuse. This is the... Which ones do we care about? Opposite and hypotenuse. We don't care about adjacent this time, so this one's a little different. Which trig ratio deals with that? Sine. Opposite over hypotenuse, right? What do we put next after sine? Equals, do your fraction. 38 over x. Remember, as soon as you do that, put a 1 under your sine. Next step is to do what? Take your calculator and find the sine of 8 degrees. So grab your calculator. Don't hit second this time. Just find the sine of 8 degrees. Before I let anybody answer, if you give me an answer like 1.6283, what do I know? It's wrong. Because what I tell you about sine and cosine? They're always less than 1. So your answer should come out to be point something something something.
I got 0.39.
All right, everybody try it again so that we're on the same page then. Because I haven't even done it yet, so I don't have a clue. Which question, Mackenzie? You better hurry up. Charles, what are you saying it is?
0.1391.
0.1391. Is that what everybody's getting? Right, that's not what you're getting? Are you hitting second?
No.
So you're just hitting sine 8. Good. Right. So see, this is why I need to know this, because if that's not the right answer, then we need to go into mode. See that right there? It's in radians. We don't want it in radians, we want it in degrees. Oops. We gotta go down to that, go over that, hit enter. Then turn it off, go back, clear. Now try it. Sine 8. So make sure if you're getting like he had 0.9, that's because your calculator's set up in radians. And if it's in radians, it's going to give you the wrong answer on all this stuff. What was it again? 0.1391 over 1 equals 38 over x. Now what do we do? Cross multiply.
38. And then
Cameron did the hard one. 38 times 1 is 38, right? What's the other side? 0.1391x. How do you solve for x? Don't let this confuse you just because it's got this silly, crazy big decimal here. If it said 2x, everybody in the room would know to divide by 2. If it says this crazy number times x, then you divide by that crazy number. When, because Charles has got confused sound in his voice. When you divide a number by a decimal, what should happen to the number? It gets bigger. And you can tell, this is, 0.1 is 1/10, right? So what you're saying, when you divide by 0.1, it's going to get about 10 times bigger. Okay? So, is your answer about 10 times more than 38?
273.
Yeah, that's pretty close, isn't it? Because we still got this, I rounded off to 0.10 instead of, so what's x equal?
273.1847.
And I think they said rounded off to the nearest whole number, didn't they? Because they wanted nearest meter or something.
Yeah.
So how many meters is she from her car? 273 meters from her car. Picture. So number one off of, which worksheet is it? The one that says Geometry A, Trig Ratios Worksheet.
That's our fourth one. What next? Nobody. Am I supposed to do it all?
They want you, I was gonna let you do it all, but you can write.
Alright, so
They want you to find the sine, cosine, and tangent of angle E. So let's just put an arc and angle E there so we know which angle we're dealing with. Now let's label that triangle.
alright, let's do the hypotenuse.
Cameron jumps right to the hypotenuse. He knows where that's at every single time, right? It's across from the right angle.
Alright, this is adjacent.
That's the adjacent because it's hooked to angle E.
This is the opposite.
That's the opposite. Now the bad thing here is, does he know the hypotenuse?
No. So
Two different ways you could find it. You could use what? Starts with a P, the easy thing. Pythagorean theorem. A squared plus B squared equals C squared. So you could use that. But looking at what we have there, does anybody know off the top of your head what this hypotenuse is going to be? It fits one of the families that we talked about. 13. So Cameron can just write 13 in there. He doesn't have to go through all that work if he remembers that that's the 5, 12, 13 family. Now he's going to come out here. He's got all his sides labeled. He's going to write sine angle E, cosine angle E, tangent angle E, using the abbreviations, right? So sine, big E, cosine, big E, or COS, big E. Sine deals with which two parts? Remember your SOHCAHTOA,
opposite of hypotenuse.
opposite over hypotenuse. So let's write that in there. Draw your fraction bar and 12 over 13. Everybody agree with that?
Can you guys see that very well, or should I change it to a different color?
Can you guys see that?
Change it to white, I can define that.
Cameron, you're gonna be a great teacher.
Cosine, what's cosine deal with?
Adjacent hypotenuse.
Adjacent over hypotenuse. Will that reduce any? No. Tangent, which two parts does it deal with? Opposite over adjacent. So what's that?
12 over 5.
12 over 5. Now, when I say, will that reduce any? Yeah, it would reduce to a mixed number. Do we really want it as a mixed number?
No.
So just leave it 12 over 5. Did they ask us to do anything else?
No.
They said find the sine, cosine, and tangent. Is it all right to leave them in fraction form? What other form could you change them to? You could have changed them decimal. They didn't ask us to. So why do the extra work?
What is going on?
So we're looking for a side this time. What's the first thing you got to do in our triangle? Label it. Side. Does he know which angle he's wanting to deal with?
Yeah.
How do you know which angle you're wanting to deal with? The one you know. All right, or the one you're looking for. This time it's the one you know. So he's going to label it opposite, adjacent, hypotenuse. I can't see the board, so is he labeling it right? Okay. Everybody agrees with Cameron what he's got? Opposite, adjacent, hypotenuse. Now he's going to write an equation. Well, first one of those sides we don't care about, right?
And it's this side.
That one, so just mark it out. We don't care about it. Which trig ratio deals with the two that you got left?
Tangent.
Sine, tangent, which one is it? Sine, tangent, cosine. I've heard all three now, so we gotta be right somewhere.
It's tangent.
Sine,
Sine's opposite of
Everybody else is science.
so sine, so write down sine,
And then I write X, right?
then your angle, no, not x, because you know the angle this time, equals what over what?
X over 17.
Everybody agree with that? X over 17? Sine says what? Remember your SO part. SOH, so what over what? Opposite over hypotenuse. So what's it going to be?
17 over X.
17 over X. That's what that SOHCAHTOA is for, to help you remember what goes on top of what. What's he do next?
Get against the decimal.
All right, before he finds the sign, what are we going to do? Put a 1 underneath it, then we're going to do that. So put a 1 under sine, then find the sine of 26. How you going to do that? Grab your calculator and hit sine 26.
What do I write? Just blank
Right,
here.
right underneath it.
All right.
Point what?
4.
4383. Everybody agree with that? Is that what you got on your calculators? Again, if you didn't get that on your calculator, I need to know so that you're still, so that we can fix your calculator.
Yeah, I am big.
We cross multiply. I'll even help you out here. 17 times 1 is 17 equals, now you're on your own. Now what's he got to do? Divide both sides by that crazy decimal, 0.43, whatever it is. What should happen when you're dividing by a decimal like 0.43? The number should get bigger. So what's x going to equal?
What do you think's so
39
funny?
degrees. 8.
What is it?
39.
39?
It looks like China.
You know what he thinks so funny is that he's been sitting there not writing any of this down.
Yeah, me either, but I get
He's,
credit. Sort of.
See, he's been sitting there. You're doing his homework for him, Cameron. That's what he's thinking is funny. You know what? This isn't very intelligent that I'm not writing down these
Maybe I
answers.
got the answer.
39.
39.
Now hold on. Let's not say round it to the nearest whole number.
No.
So let's go to the nearest tenth since it's the length of a side. So what is it? 38.8. If you're finding a segment, go out a decimal place or so. If it's an angle, nearest whole number. Probably got time for one more. Somebody pick him another one.
Number 6.
Oh, what is this? Is this the right button, right?
Then
Is this
no,
one, right?
the indented button.
This one?
No.
Oh, I hit that one. I just didn't know. Oh, I didn't know. Okay. All right.
Which one? 6. Oh, you should have flipped over and made him do one of the back ones.
Number 11.
All right.
I'll read it for you. You are preparing to land an airplane. Your straight line approach has an angle of depression of 3 degrees. So I guess straight line, see if I was a pilot, I probably know what straight line is. I guess straight line approach would be this.
So just draw something like
So,
that.
yep.
All right.
Now draw a line coming straight across. There you go. And then now finish out your triangle on this side. So that angle up there at the far corner,
Right here.
that's your angle of depression, is 3 degrees. What is the straight line distance to the runway when the plane is at an altitude of 500 feet? So where's the altitude go on
Right
there?
here.
Right hand.
How about on this side?
Oh, well, I mean,
It'd be the same thing, right? So
this is.
that's
100 feet.
500. And we're looking for the bottom, so we're gonna call it what? We're looking for this here, so we're gonna call it X.
Right here.
Yep. All right. Which angle is he gonna Forgot the word. Label his triangle according to.
Everybody agree with that?
Where's your right angle? Let's put it in there so everybody sees it. So X is the hypotenuse.
500 is the opposite.
How come 500 is the opposite?
It's across from the angle.
It's across from the angle that we're wanting to deal with, right? And then the other's the adjacent. Which one don't we care about this time? Adjacent, so let's get rid of it. Which trig ratio deals with opposite and hypotenuse? Sine, everybody agree with that?
Yep.
Is it sine? So we set up our equation, sine,
3 degrees.
3 degrees. Remember, it's always the trig ratio, the angle.
And then what? 500
So,
for X.
opposite over hypotenuse, so 500 over x. Put a 1 underneath it. Somebody help him out. Let's hurry through this. What's the sine of 3 degrees?
0.0523.
Instead of writing it all out again, Cameron, let's do this. See right here? Mark that out and put it right there.
What is it? Point? Alright.
0.523.
I thought you were making that your decimal point. I was going to be upset with you because you've been doing well up to this point. So we cross multiply. I'll help you out. 500 times 1 is 500. So divide 500 by that 0.05. See a lot of confused looks on your faces, but because you probably got some great big huge number, didn't you? Because when I divide by 0.05, it makes the number really, really get a whole
So
lot
what is
bigger.
it, like 1,000 something?
9,560.
9,560 feet. Is that all right for an airplane to be 9,560 feet away from the runway?
Yeah, we hope.
Yeah. Let's hope they don't get up to about 1,000 feet from the runway and then start to try to come down and land. That's not going to be a good thing.
Let's start from there.
All right. This one, Cameron did a good job because he picked the right one. This one is your homework. It's got 14 problems on it. I think we've already done like 4 of them, right? 3. 3? No, that's because you were sleeping for one of them, the one that you didn't realize.
Is the other one extra credit?
This one, maybe. So if you do the other one, maybe next time I'll say it's extra credit. The other thing, the packet will be collected next class. Yeah, next class. So this and the packet due next class. The packet should already be done.
This is yours. I need more of it.
Make sure you don't forget your calculators again next time. You don't want a detention. I was pretty impressed. I didn't have any detentions today. It's only a bad thing for you, though.
That's how mine started. And once the thread's broken, just every day get a little bit worse.
I had this bad feeling. I've been acting awful tired. I said we did my class here last few days.
I'm not allowed to fail because there was something where I was hanging out with the wrong crowd and I put on probation. If I fail one class in the middle of juvenile detention, so I gotta work up my grades.
I have a really